on two types only. The other third type, not very important, right? Now, first one, displacement time graph, right? So we're going to look at displacement time graph. Okay, why everything gone? Okay, never mind. Now, there are three things that you need to know regarding this displacement time graph. How do you know this is a displacement time graph? You look at the label on the x-axis and the y-axis. So the label on the y-axis is x, and it represents the position. The unit is in meter. And the label on the x-axis is t. It is time. It represents time, and the unit is in second. Okay, fine. Okay, so we know that this is a displacement time graph. Now, for displacement time graph, if they ask you what is the displacement, you can read directly from the graph. You don't have to find anything. The displacement, you read directly from the graph, right? And they ask you what is the time. The time also you can read directly from the graph. Okay, so these are the first two things that I want you to know lah. The displacement is given on the y-axis. The time is given on the x-axis. Now, the next thing that is not given in the graph that you need to find is the slope of the graph. The slope of the graph represents the velocity. Okay, again, it can be positive, negative value, it doesn't matter. So this, you need to remember this one. The slope of the graph represents the velocity. And this is true only for displacement time graph. Okay, right. So now we look at the first one. So let's say I look at this point here, 0, 0. 0, 0 means when the time is 0, the position is 0. The position is 0. Then you look at the ending here, the last point on the graph. Actually, it is 997, right? 97. It means that after 9 seconds, the position is 7 meters. The displacement is 7 meters. So if you look along this line, as the time increases, the position also increases. So this is something that you should note from the graph. Right? This is how you are going to interpret the graph. Okay, so if it is a straight line like this, it means that as the time increases, the position also increases. Now, what does this mean, right? What does this mean? Okay, we look at this. Okay, the first one, let's say I pick a point there, 0, 0, a point on the line. So it means that when the time is 0, the position is 0. And I pick another point, 97. It means that when the time is 9 seconds, the position is 7. Okay, now for this type of graph, displacement time graph, the slope is actually the velocity. The slope is actually the velocity. So if I ask you to find the velocity, then you just find the slope. How to find the slope? Because you have 2 points there, 97 and 0, 0. So the slope is 7 minus 0. You use the y coordinate minus the y coordinate. 7 minus 0. 9 minus 0. The x coordinate minus the x coordinate. Okay. It turns out to be positive 7/9 meter per second. Why meter per second? Because the top, the unit is meter. The bottom, the unit is second. So finally, the physical quantity has a unit of meter per second. So calculate the slope and it will give you 7/9. And this 7/9 is meter per second because this is meter and this axis is second. So the unit is meter per second. Now I want to ask you, the velocity, is it constant or is it changing all the time? This is a straight line.
Velocity will be changing, right?
It
It's
is
increasing.
the position is increasing. The position is increasing.
But the velocity will be the same.
The velocity is the same because the slope along this line is always the same, unless it is a curve. If it is a curve, then it will be different. It will be changing all the time, right? So this one, the straight line, shows that the velocity is constant. Another thing, the positive sign here shows that it is moving in the positive direction, right? It is moving in the positive direction. That means from left to right, right? If we follow our normal notation. Next one, okay? Velocity is positive, means that it is moving in the positive direction. Positive direction, you can mean saying going forward, or you can say it's going to the right, right? So two things to note here. The first thing is the velocity is positive and the velocity is constant. It's a straight line. Okay, any questions so far?
No, sir.
No, but what I've said here it only applies to this displacement time graph. If it is another type of graph, then this thing is not valid anymore. Okay, now you have to check whether it's displacement time graph or velocity time graph. Okay, right. Next one. Next one, I pick 2 points from this horizontal straight line. When the time is 0, the position is at 8 here, right? Now you look at my stopwatch, where is this person? Oh, he's 8 meters, not, yeah, 8 meters. Then I look at my stopwatch after 10 seconds, he is still at that position 8 meters. I look at it, 8 meters. Now I'm going to do something else. I learn back. He's still at 8 meters there. So this horizontal line tells us what? He's always at 8 meters. He's moving or not moving. His position is fixed, always 8. So actually, because the position is always at 8 here, right? Even though the time keep on changing, different time, I look at him, he's still at 8 there. It means that he is not moving. Now, another way to decide whether he's moving or not, I try to find the slope of this line. So since I know 2 points on the line, so I use the y coordinate minus the y coordinate, 8 minus 8, right? Then the x minus the x coordinate, x is 10 minus 0. So 8 minus 8 is 0, 10 minus 0 is 10. 0 divided by 10 is 0. So it means that the velocity is 0. 0 means it is not moving. The object is not moving or stationary, right? Any questions so far? So to summarize what we have done so far, slope means velocity. Slope means velocity. Straight line means constant velocity. Horizontal line means not moving. Okay, now? Then we look at the last example here. I choose 2 points on this straight line here, on this straight line. At first, type wrongly. It is 0, 7, 0, 7. So initially, when the time is 0, I look at my stopwatch. When the time is 0, the object is 7 meters away. 7 meters away. Then after 12 seconds, 1, 2, 3, 4, 5, 6, and so on. After 12 seconds, I look at the object. It is at 0 position there. At first it is 7, finally it is 0. So we see that this, as the time increases, the position decreasing, the position is decreasing, unlike the first one. The first one, the position is increasing with time. The second one, the position is decreasing with time. Okay, this is what we should take note lah. Afterwards, I will explain to you what is the meaning of the position decreasing with time. Well, we try to find what is the slope of this line. We try to find what is the slope of this line. So I use 0 minus 7, the y coordinate minus y. Then 12 minus 0, the x coordinate minus the x coordinate. Now 0 minus 7 is negative 7. 12 minus 0 is 12. So it's negative 7 over 12. The gradient is negative 7 over 12. Okay. What does this mean? It means that because the slope means the velocity lah. If the slope is negative, it means that the velocity is negative. Okay. Well, what is the meaning of negative? Negative means it is moving in the negative direction. Or you can say that it is moving backwards. Instead of moving away, it is moving backwards. Okay. Or you can say it is moving towards the left side. If this is the right, then it's moving backward. It's moving towards the left side. Okay, right. So overall, we try to compare these three types of graph. If the graph is going up like this, it means that the velocity is positive. It is moving away from the center position towards the right-hand side. Now, if the graph is going down like this, it means that the object is coming back. It is coming back because the displacement becomes less and less. So it shows that the object is coming back. If the line is horizontal, it means that it is not moving. So how many types of motion are there? 3 types. What are the 3 types? Moving away and coming back, or not moving at all. Okay, not moving away or moving back, or not moving at all. Moving away, velocity is positive, right? Moving to the right-hand side, velocity is positive. Then moving to the left-hand side, the velocity is negative. And it is shown by the slope of the straight line. So far, any question or not? You compare the 3 types of lines, and you more or less, you try to remember by looking at the shape of the line, what does it mean, right? Looking at the shape of the line, what does it mean? Okay, right. First one, like that. Going up, what does it mean? Position time graph going up, what does it mean? Moving or not moving?
Moving.
Moving. Moving in which direction? Positive direction or negative direction?
Positive.
Positive direction. Now let us look at the third graph. Third graph, this one, third graph, the extreme right. This type, the line coming down like that, moving or not moving?
Moving.
Moving in which direction?
Negative.
Negative direction. The line horizontal like that, moving or not moving?
Not moving.
Not moving. So this is what you need to recognize. So if it is not moving, velocity is 0. If it is moving, then you have to say, you have to find the slope of the line. Right? You have to find the slope of the line to determine the actual velocity. Displacement time graph.